Now, let's discuss boiling point of amines. Primary amines, they are polar. If you can see here, the dipoles, they do not cancel each other. That's why amines, they are polar. If you are going to compare amines and how they can bond with other molecules, we can see that the nitrogen molecule, it is less electronegative than the oxygen in the alcohol. So that bonds that can be formed with amines, they are less strong than those formed with alcohols. This can leave us to conclude that methylamines, they have a less boiling point than that of alcohols. This is because of the fact that methylamine, they form poor bonds with compounds more than those of alcohols. Short chains of primary amines like methylamine and ethylamine, they were found out to be gases at room temperature. So, primary amines, they can easily form bonds with other compounds because their NH2 group is found at the extremity. Let's take a look at this table here. You can see that primary amines, they have higher boiling points than those of secondary and tertiary amine. This is again due to the fact that the nitrogen atom in the primary amines, it is located at the extremity of the molecule. However, in secondary amines, the nitrogen is found in the middle. They can hardly form bonds with other compounds. That's why they are easier to break than primary amines. Secondary and tertiary amines, they have something special about them. They have fishy smells. The smell of rotting fish, like the one you see in the picture, is because of di and triamines, which are produced when proteins inside the fish, like this one, decomposes. Let's now examine the solubility of amines. As we have learned that primary amines, they are polar. Because their dipoles, they do not cancel each other. So, they are soluble in both water and alcohols. They can dissolve inside water and alcohol because both of them are polar. However, there is an exception here, which is phenylamine. Phenylamine, yeah, it is a primary amine, but it is not very soluble in water due to the fact that benzene is nonpolar. We have learned in the previous chapter that the benzene ring is nonpolar because all of its dipoles cancel each other. The best example you can see about phenylamines are in the lava lamps. These beautiful structures and colors you see inside the lava lamp is due to phenylamine. These are phenylamines because they are not soluble in water. They float like that inside the lava lamp. Now, let's discuss the reactivity of amines. Amines, we have said that they have a lone pair of electrons, which makes them more reactive. So that lone pair makes the amines very reactive. This lone pair might form a bond with an H plus ion where the amine is acting as a base, and it can form a bond with an electron deficient carbon where the amine here acts as a nucleophile.